Okay, good evening all. Good evening all. Good evening all. Okay, I'm Emmanuel Lebeku by name. I'm on Emmanuel Lebeku, and I'm taking you on this PCB and electronics for this boot camp. So, and for this boot camp, we only have 3 days to cover a lot. This PCB and electronics is kind of broad. Yes, it's really broad, and we have 3 days for this for 1 week to cover this whole thing. So for the first day, which is today, I will be teaching you the simulation part and maybe introducing you to some components we know about. And the second day, which is next tomorrow, Wednesday, Monday, Wednesday, Friday, right? So Wednesday, I will be teaching you the practical aspect of it, physical aspect, and then on Saturday, I will be teaching you about the PCB. When we talk about PCB, you're talking about no PCB. No, who is there that doesn't know about PCB? Huh? Okay, PCB is printed circuit. This thing, printed circuit board. So let me show you something like this thing is a PCB. Sorry, I'm coming. This PCB, listen here. All those components, maybe all those electronic components being on a board, a single board. You're not seeing all those wires, you're just seeing copper traces in the board. So all of them are all those things are PCBs. So printed circuit board, printed circuit board. So converting all those wires, so everything inside one board. Maybe you have your Arduino. Okay. Don't mind me, it's not as clean as first of all. Something like this now. This is a PCB, but it's an Arduino. But this board that all these components are being sold out of is PCB, printed circuit board. So all those wiring, they are being done on the board already. So you just mount your component on it and it's connected. So within these 3 days, I'll be teaching you on that. So this particular part, which is this electronics and PCB, is very interesting. It's something that's very easy to understand and something that's really complex. It's something that is kind of maybe while learning it, you like it, but at the same time it gets boring. Yeah, you can easily get bored and with this particular stuff and can easily it's something that is easier. It depends on the view, your parts, how you view it, how easy it is for you to understand. I'll try to make it more easier. So I'll start by maybe you already wasted some time. So I was supposed to use 30 minutes to introduce you to some components, but maybe let's just start. Okay. Okay, this legal advice is just from me to you guys. So I always tell people to try to maintain their CSB. CSB is just an abbreviation, meaning CG for people can call it certificate. Me, I call it CGPA. C for the C. Then the S is your scale and the B is your behavior. This is how it works. Your CGPA, which is certificate, will take you to a certain level. Then your scale will keep you on that level, but your behavior will sustain you in that level. That is try to balance your CSB while being in school. So your CGPA, which is the C, will take you to a certain level. You might see someone maybe having 5.0 coming out from school, but low scale, like very low scale. So that person now, the CGPA will take that person from this height to this height, but with zero scale, that person will fall drastically. That is it. So if you try to balance it, maybe you don't have 5.0, but you still have 2.1, which is second class upper, something like that. So your CGPA is good enough to take you to that certain level. Equalizing with your skill, it will keep you on that level. So we no go maybe your behavior, which is really important, sustain you in that level. So that's my advice to you guys. And introducing you to some components. Maybe before we start, hmm? The B is behavior. C certificate or we call it CGPA, that's what I call it. And the S for its skill. So introducing you to some components. Uh, these are the components, some of the components you'll be using. Or maybe before we start from this, I want to tell you something about this water. Let me just use this water for something. I want to introduce you to electronic current and voltage. Who is there? Anybody here that doesn't know the difference between current and voltage? What is the difference between current and voltage? Why is it different? So, actually, it took me time. Okay. That's just it. Actually, it took me time to understand what's different between current and voltage. The current is one that flows, then the voltage is the pressure. Just like maybe let's go to that side. Around voltage. But in certain cases, you know that let's assume you have 5 volts. Okay, sir? Yeah. The speed at it flows, and speed the water flows. So regarding your question, maybe you have 5 volts and there's what we call booster. Boosters. We want to boost it to 12 volts. Maybe your system needs 12 volts to boost. So you only have 5 volts. So to boost it, use the booster to adjust it. Now, as you are adjusting, as you are increasing the voltage up to 12 volts, you are decreasing the current flow. You get? Because you are just increasing the speed. You are just like this water. You are now tightening the mouth. So the amount of water that is coming out of it is small, but with high voltage. So if you want to boost, the kind of question you ask, which one is more important or what do you ask? Yeah, if you want to boost it. But in normal cases, something like you see a battery 3.2 voltage with something like 170 amp per hour. You get? But you might see another thing, you might see something like 12 volts with 7 amp per hour. See how they move. So you have 12 volts, but you have lower current, 7.2 amp or so. So introducing into all these components, this is the resistor. What it does that limits current. So something like go let's look into this now. You know what I just said. Sorry. So you see now, sorry, you see that this current is flowing, but let me go back. Okay, you see that current is flowing, but you still have some things that's like hindering the distance, the flow of the current. So this thing that is hindering is resistance, like it's trying to put resistance between it. That is what the resistor does. Just to bring resistance between the flow. Just decrease it. Let's watch the video to the end. So this is how it works, the whole theory about how it works. So you see now that this one only has this one tracing or what I call it, this graph. You see that it goes more fast, but this one takes time because the time it should take to go to this thing before it comes out. So this one now is high resistance, ready to this. So come to capacitance. What capacitance does is that you have the electric plate. They have an electric on the center. Then you have two plates. So once it charges, just like to store energy, to store voltages, to store energy. Nothing concerns current when it comes to capacity. Nothing concerns current there. Just about voltage. When it comes to capacity. So it stores that voltage and maybe it's for a certain time. Maybe you want to use it. You want to use it to filter signals. So like you have a signal that is oscillating at a very high signal, that high. So you can use a capacitor to filter it. So instead of moving like this, it's not moving like this. No. But you filter it to a certain straight line, but not that straight because you not actually get that straight line you need. Now talk about diode. What diode does is that it allows the current to flow only in one direction. It flows like this, but if you want to go like this, it will limit it. Yes. So you can only go only in one direction. You can't go the other way. When talk about the Zina diode. Zina diode does the same thing with this, but this can maybe if it's a 5 volt Zina diode, it can only allow this thing to flow, but if the voltage that want to go the other way around is above 5 volts, it will allow it to flow. It doesn't allow the voltage current to flow this way, yet to flow backwards. But if the voltage there is above 5 volts, let's assume that it's 5 volts this thing. If it's above 5 volts, then it will allow it to flow. It will allow current to flow backwards. Do you get it? Hmm. LED. Okay, yeah. The LED is a this thing, but it's a how will I call it? No, it's not a photo diode. It's a this thing, light emitting diode. So you just allow this thing for this person, how will I call it? For lighting also. I don't really know how to explain, but you know what LED is. LED means it's for lighting. So, but you notice that even in that LED, if you put it back way around, put back the other way around, the bulb will not on, but you put it the other way around, the bulb will on. The LED will on. And talk about the transistor. Are we supposed to be on this one? No, sorry. Okay, talk about transistor. So transistor is just like switch, normal manual switch. That's what transistor does. I use it for switching. Maybe this electronics switching. That's what we use it for. I've also used it for amplification to amplify small signal. Maybe you are getting 0.2 volts with small mini current. Then you can use transistor to amplify it, like BC 547, 557, and all of them. You can use transistor to amplify and also use it to switch. Same thing with the MOSFET. But difference between MOSFET and this, you see that this base, collector and emitter. This one is gate, drain, and source. The two does the same thing, just that this one uses voltage, this one uses current, and this one gets hot faster. And so this one can take enough heat than this. And maybe next thing is this one is mainly used for high loads, to switch high loads. This one is for small loads. Any other thing. This one switches more faster than this. You get the differences. This one uses current on the base to switch. This one uses voltage on the gate to switch. This is MOSFET. MOSFET, metal oxide semiconductor field effect transistors. So the two are transistors, but this one is BJT, bipolar junction transistor. This one is MOSFET. So remember, this one uses voltage at the gate. This one uses current. This one switches more faster than this. Takes more current. This thing more heat than this, and used for high load. Okay, this one is autocoupler. In this place now, I talk about the Voltavoid effect also. Autocoupler, what it does that this one here is a photodiode. Inside the chip, this physical, this is how it is in real life. But inside it, you have LED. Like then you have a photodiode this side. What it does that once this LED on, this photodiode will collect those light rays and use it to switch. Then it allows current to flow through here. But once the LED is off, it's not allowing anything to happen here. This something like this. Just that instead of having this to flow into here, we're using LED inside for switching. So in this our policy, we also use this. We also use most of them. We might not use this to this. We also use all of this. Mhm. This. This one. This this photo image. This autocoupler. So who doesn't know this one? Doesn't know this. This fuse. So maybe you all know what it is for. Maybe assume you have 2 amp fuse and your system once it draws more than those 2 amp, fuse will just break to protect your circuit. And this is a NTC thermistor. So it's also a resistor. It's also a resistor. Just that the resistance changes fast with heat. Resistance, heat affects resistor. So the resistance changes with heat. So the resistance changes with heat. So we can now convert the heat into voltage using voltage division and all those things to now bring out what we need. So we can also use it for temperature sensing. Apart from this, NTC thermistor. NTC, but it's a thermistor. The name is thermistor. But yes, but for this particular one, just NTC. But the actual name for all of them is thermistor. So we can also use there's another this thing called a LM35. LM35 is also a temperature sensing component, just like this. But that one is already meant for temperature sensing. But this one is for resistance, change resistance. Then we convert it, use it for temperature sensing. This relay, we mainly use relay for high switching. Um, this thing here is coiled. This is a relay coil. So when you connect your battery and switch it on, like this thing is built up, current is built up here, and now it now either actually this or repose it to connect to this one. So you have your bulb that is connected to this, and you have the other source to complete it. You have this, and have the other source to complete it. Once this is energized and either attract or repulse it, it now complete the circuit. So that's what we use relay for. Maybe you are in this place and inside this place is really hot, so maybe you can't really enter here to do some switching, but you can use a relay, have small switch here. Once you turn it on, it will energize this relay, and inside that place the circuit will become connected. You just need to bring out the wire for the switch and keep it outside here, then keep a relay inside for the switching. You also use it maybe in bulbs and other things. That's when you come into a room, you see that they're using somebody is using mobile phone to turn on the LED and other things. So you're using relay for that. Maybe the embedded system part of this boot camp, they will teach you about that. So actually we built it. So tomorrow, next tomorrow, you see the practical part of it and we simulate it. Maybe today if there is time. We already wasted some time already. Okay. Hmm? Yeah. Okay, I'm not refuse. Or this is just this is a fuse. I don't know how to type of fuse now. If you see in the market, or these are just fuse. These are just fuse. So this is a potentiometer. Have thermal potentiometer. We have a preset thermal potentiometer, but this is normal potentiometer. This is normal potentiometer. You have the one that will be like block form. I use small, something like screwdriver to adjust. So with this thing, circle, use something to adjust them. But this normal one, used to see in maybe radio, all this what's it called? Home theaters that is in home, all this touch, this normal one we see there. So it's a resistor, but it's a variable resistor. You can change the resistance to either show a brighten light or do something else or change voltage. So this one is a LDR, light dependent resistor. So it's like resistor, but resistance changes in response to light. So based on light intensity, resistance changes. Yeah, exactly. Something like the same process of autocoupler. Not actually what's inside autocoupler. Is okay. Let me come. I'm coming. Okay, inside this autocoupler now, this is the particular one. This is this LDR I'm talking about. But inside this place, there's nothing like light rays or so. It's just using LED. But this LED, this thing is not this normal LED you see. This is not really visible. It's not something you see. So just like UV light and all those. Hmm? No, 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 no. It's a transistor. It's a transistor. Just that it's a modernized sort of dish. modernized. You can use this for to do higher stuff than this. Yes, it uses LED to turn on. So this LDR uses the same principle for that. But this one uses sun rays, this normal light and other things. One that is visible. That's what this one uses. LDR, light LDR, light dependent resistance. So this LM358 IC. So we'll be using this for this our system also. It's a I call it amplifier. So this is an amplifier. Use it to amplify more voltage. You have maybe from your system you design something that's giving out things in millivolts. You can use this to amplify the voltage and some other things. So use it for amplification, use it for compare voltages. So what's the main work of this thing is to compare voltage. Use to compare voltage to give out the voltage difference. If this is not really bright, but here you have GND, here you have VCC. VCC is voltage common collector. That's me. So from the embedded system part, you'll be hearing this short this is like VCC, GND, COM, common ground, GND is ground, VCC is common collector. This is where you put your 5 volt battery, the positive part. Here is GND is where you put your negative part of the battery. So here is your output. You see this sign here is comparator sign. Comparator. So what it does that it compares here the inverting and the non-inverting. Compares the two inputs. And then you have your uh, okay, maybe you have this thermistor. Sorry. I have this thermistor. And after doing the change, after doing the calculation and getting the voltage output, you put it into the non-inverting, the inverting part of it. Then you put your potentiometer, which will be using thermal potentiometer in the inverting part of it. So it compares the two and then give out the voltage. That's what we use it for. So we can use it to do a lot of things, maybe proximity sensor, these light dependent sensors, LDR sensors. I use it to do temperature a lot. I use it to do a lot. And 358. So it's something you will see market also. Yes, yes, yes. It's anywhere you see GMB is ground. Okay, to complete the circuit, let's assume there's no marker. I really need marker. Anybody with marker? So this is the actual sign for GND. So when you have something like 5 volts here that's coming in, and you have your LED, you have your resistance, have your LED. So that's coming. If there's no GND, this LED will not on. GND is to complete the circuit. It's just like your positive and negative battery. If you plug a battery, the positive part here, and you don't connect the negative part here, it's not on. That's all. No, GND is not a component. It's just like signal is not a component. It's just GND is it. But maybe during the process we still see because we still do simulation. So it's not a material. No, see, we say that let's assume this part, this whole copper core here is GND. So then we make our GND and connect the GND part, like the negative part of the wire off. your battery to this whole GND. Anything you tap, anything you connect that needs GND, just go and tap from that GND, connect it to GND. Anything you need, connect it to GND. So everything have general ground. Don't worry, you still get understand it. Like I said, the course is this thing is really easy, but you might get confused somewhere. I might get bored. This transformer. I need to explain this. And calm down. They talk that yes now. Okay. Okay, I think the only thing I need to say is about this. You have step down transformer, have step up transformer. So for step down, the primary side have to have higher than the, but for step up, the inverse side lower, this one higher. Okay, so for the this thing we'll be using for this whole stuff are the embedded simulation, which we'll be using next week. I don't know if the person will actually use this stuff, but we also for the electronics part we also make use of this. You can use what Proteus. Proteus is a software you can have it in your laptop. Then WorkWire is a website own. So Tinkercad is also a website, but you can also add it to Google. So circuit design and what circuit to and circuit for this particular one. Circuit design, that's what they use. So all of them, this one is more advanced than all of them. This is still they still have some there's still some components you will not see in this one. WorkWire. Same thing to Tinkercad, but for WorkWire and Tinkercad, probably all of them. What this one you can put your code. If you have for the embedded system part, you can write code into it to automate it. So you can either write code to automate Proteus, WorkWire, Tinkercad, and circuit design, but this is more preferred. And for those mechatronics, you might also get to this and this. And even this one has all the components, but some are still not usable. Some are still you can simulate some, but they are still building it. Then for this one, you can simulate everything. If there's no component that's not in the app, you can import it and you simulate it for this Bluetooth. Then for the electronics part, we also use WorkWire, also use Tinkercad, both in Proteus, same thing. So we'll be using VoteSim. VoteSim is for mobile. So like I earlier said, for those that couldn't get laptop at the moment, because you can use VoteSim. I use VoteSim on my phone. I use VoteSim. You can use the Proto. Yeah, mobile. Every circuit. I also use every circuit. And Falstad is website. But among all of them, I way prefer VoteSim. Yes, for some reasons. VoteSim for mobile. VoteSim. Vote simulation. Vote simulator. So Proto is also good. This one is also good. But the interface for this one and more easier. So it's more easier, have more better interface. So for today we're using Falstad and maybe for those that will use their phone to do the vote sim. So for the keycard, for the this thing, for the PCB part, we're using keycard. So like we will have more to say the able. This one is related to Autodesk Inventor. So maybe I've told you something about CAD. Come across Autodesk Inventor. What do you guys use? Precard. Okay. This not that, but this one now is related like just an same company that of Inventor that does a CAD for Ego. Okay, you can use Flux. Flux. One thing about Flux is that Flux has some inbuilt AI that can help you to maybe if you have face error, also maybe if you want to design some circuit that you could so Flux will also kind of help you, but not suggested. No, it's not that kind of way recommended because uh, you need to pay for this. You need to pay inside. You need to pay for auto designer. But among all of them, auto designer is the best. Auto designer is the best because auto designer instead auto designer can do flexible PCB design. This flex, flex. You can design flex inside auto design. You can design for the moment. I don't think there's any of them you can do that. Easy EDA is kind of trying to do that, but at the moment, auto design is the best for that. But we're using KiCad. KiCad Altium. Altium designer. So I will be using KiCad. KiCad is free source. It's free. So I will be using it. No, KiCad you can download it as a software. No, KiCad. KiCad or KiCad. I don't know anything you call it. So you're using it and the software, both system are already introduced. You can also use ECDA, it's free. These two are free, but these ones are paid. Okay, I think we're kind of done with this. Then let's kind of head into our main reason, main thing. Okay. Uh-huh. Not today. This tomorrow. You know what that is? That you know what it is, right? Breadboard. Okay. You know how it is? How the traces are done? Done like this. Breadboard. Breadboard. Yes. Yes. In the market, they're everywhere. Just they're everywhere. All these not all all the component to not all the component, most of them, but all the ones I use here, I showed you here are the ones you can get in market. It's everywhere in market. So and all the ones we'll be using here, we'll be considering market analysis also. So like I said, let's go into first start. We have network. If you have your laptop, go into first start right now. So inside here, we'll be simulating everything we need. I'm like all those things we talk about PCB. So we simulate everything here. We build it real life and then we turn it to PCB. Where is the PCB? Let me show you something. Just show you intro. So this is PCB and this electronics this thing traces. So all these things, all these copper traces you see, all these small copper traces are those wires that you need to connect and all those things. So all these things are copper traces. This one that is big here is copper core. You pour the copper and going to 3D part of it. So here you see the what you design in the key card. Then from this, if you have this, if you already designed this, you can now export it to um, company like PCB way, JLC PCB, more other companies. But all these PCB or just PCB are not in Nigeria; they are outside. But you can export to them. Then when they are done designing, then they import it for you. Or there's one PCB design list that is in about. So I heard about it. That's in about. You can if you don't design the PCB, you can send it to them and they will print it for you. So for the moment, let's start with temperature sensing. Talk about temperature sensing. Let's start with it. From your laptop, go to file and then go to new blank. Time is running. Are you there? New blank. This file, go to file. New blank circuit. Circuit. If you have it to your phone, download WorkWire, or you can also go online and search for start. Then you can add it to your home screen. Hmm. I know. Even that. But there's one thing about vote sim. Vote sim, there are some components that we need to pay for inside it. So it depends if you're using it for a very long time, you can pay for it. Because I'm using it, so I paid for that. I subscribed for it. That's why I'm talking about vote sim. But if you couldn't do that, you can use Falstad. Falstad is free. Falstad is free. Vote sim, they will limit you to some components you need to pay to use it. So, but you can use Falstad. So this is Falstad for phone users. So you can use your phone to do the Falstad. Should I write now? Let continue. Okay. So next is the components that we need. So you go to draw. Regarding this thing, what was it called? We talked about thermistor for the temperature. You can remember we said about thermistor for the temperature. So we go to our resistors. Oh, sorry. Let's get search for some coming. So you see thermistor. You go to passive components. Huh? Huh? Okay, okay, okay. Are you in first start right now? Go to file, select blank circuits. Then you go to draw, under draw, and go to passive components. I've done that. Okay, then you go sorry. You go now, you see your thermistor down there. Have you added it? So you can draw your thermistor. Once you pick your thermistor, you go and tap and draw. Yes, you tap, hold and draw. After you pick this thing, so but like we said earlier that thermistor uses a temperature to change resistance. So change this thing resistance changes in response to temperature. So we need to convert it. We need to convert it to voltage. So we're using a voltage divider. I bore you guys with calculation. Okay. So to get the convert the difference to voltage, use formula V out. Input resistance R1 all over R R1 plus R2 times V in. Use this to convert V out equals R1 all over R1 plus R2 times V in. So but in this case, is if you add the ground here, if you add the ground here, if the ground is here, that's when you use this. Because here your R1, let's call your R1 the thermistor resistance. The thermistor resistance, then our R2 now the no resistor, the resistor we want to add to convert it no resistor. Hmm? Now that's R1, that should be the resistance resistor. Then the thermistor resistor, then the R2 should be the one we want to add. So usually we use 10K because it's in medium. There's actually a this thing to calculate if you know the one we use. to know the actual value you use. To know the actual value you use when it comes to something like using it in transistor, you use um, this formula, the resistance divided by the HFE. HFE is your beta. So you use this calculation to know the actual value, not the actual value, but range you use. So, but in the market, you can use 10k ohm to give you normal, based on normal calculation and everything has been done. You can use 10k ohm. It's average, kind of average for better. So using this V out, our R1, this our distance is 10k. See 10k ohm. You see it here, 25 degrees Celsius, 10k ohm. So this R1 is 10k ohm, and the under should be 10k ohm also, plus the 10k ohm. Now if your input voltage is a 5 volts, which is what we're using actually. Now we can use it to get your V out. Your V out here should be based on resistance change. At 25 degrees Celsius, it's still 10 kilo ohm. If you reduce it, let's assume you reduce it to 10 degrees Celsius, the ohm will change, resistance will change. If you increase it, resistance will change. No longer be seeing 10 kilo ohm here. So let's assume you reduced it and the resistance changed to around 8k. And this one 8k. You see that the V out will now change because you still have your steady V in, which is V reference. So V out will now change based on resistance change, the temperature. So here now we can now go inside and some people are already getting bored. Eh? You added resistance. Take tennis stop. Go to draw. Go to draw. Are you on draw? Then you go to passive components. Scroll down. You see tennis stop. So now we go to your draw again. You add the resistor. Resistor. Take it from here and draw this way. Have you done that? No, from here. Draw it. Go to draw. You see resistor, add resistor, pick resistor, and come and tap it from that joint and draw left. Let's go to file. Blank. New one. Then I go to draw. Go to add then pick it. Just draw it. Come and add it. Come and draw it. Now you go to draw again. Go to draw and add resistor. Then tap on that junction. That junction. That joint. And draw it. Have you done that? No working on it. No, it's okay. I'm doing it. And mobile phone is no easy to have the after button like I used to tap that. Now have when then you go to add resistor and then add resistor. After we have done that, next thing is add wire. Go to draw, add we see add wire. Come and pick it on this junction and take it down. Add wire. Have you done that? I think we need to fasten up. I just need to fasten up. Okay, now we can go to this 1K ohm. Double tap on it. You see, you can change the value of the resistance. You can change the value of the resistance there. Now change it to 10K ohm. Tap. Huh? Yeah, press something. What? I try to pair up. For mobile phone, you can also use it to mobile phone for start. But just that it gets nasty because maybe if your hand touches any parts, it shows up later. So it's way that sensitive. That's why I told you guys about if you have a mouse, it's easier for you. You can connect your mouse to your phone and just use it. Because, yeah, double tap on it and change 1K to 10K. I follow you up. Okay. So next thing, somebody that asks about ground. So now let's go to input and sources. Input and sources. Huh? Resistor. Resistor brought out. So now go to your input and sources. You see add ground, you see voltage, two terminal. You see a one terminal voltage, you see AC. But normal voltage, that's why AC is normal light, this NEPA light, alternating current, that is AC. So it's changing polarity, that is alternating current. Huh? Input and source, go to add voltage source. We have two terminal, we have ground, but what we'll be using at the moment is okay. Let oh, go to draw, go to input and sources. You will see ground, add voltage, and everything. Now go use two terminals. That add two terminal voltage. Have you seen it? No, normal and AC is alternating current. You're not using alternating. You're using normal this thing. Huh? And you draw it. How to add voltage source, the two terminal. The two terminal. Huh? The two terminal one. If you have done that, then you still go and add your wire and connect this to this. So for a person that asked about a ground and everything, this person will say, yeah. So here now is your ground, part of it, and here is the positive part. Instead of using this, you can go to that input and sources. Instead of using two terminal, you use one terminal voltage and then use ground. Instead of using these two terminals disconnected, use one terminal, add it here or add it here, then use ground the other way around instead of adding this two. So to delete it, just highlight it and delete button. For those that are using mobile phone, highlight it and you see something like scissors that is cut and cut it out. So go to your draw, go to input sources, add ground, and come and take ground from here. Hmm? No, delete the wire and delete the other source. Just I use the other one so I can explain this. So actually using ground in normal, not that the other one is bad, but you make things professionally. Professional. Are you there? So for those using mouse, I think things can also get easier for you. Just, instead of going out to you can just right click. Those that is using mouse. If you're not using mouse, you can always go to your draw and add your stuffs. So still go to input and sources and you see add voltage source, one terminal. Add voltage source, one terminal. That's one we'll be using. And come and add it this side. Now see that it's 5 volts already. You go to the same input and sources, get your add voltage source, one terminal. So you see this now. Based on this current voltage that's out, have your 5 volts input in, but you have your what's it called? At 25 degrees, you have your 10 here. If you try to change temperature, you try to change temperature. Let's look at the voltmeter that's here. You see that the voltage changes based on increase in temperature. See that this temperature increased to 79 degrees Celsius, and the resistance decreased to 1.3 kilo ohm. Then you notice that the voltage here reduced to millivolts instead of voltage, now reduced to millivolts. Then let's try to reduce the temperature from this side in your simulation. Try to reduce the temperature. You see that the voltage is increasing. You see it, right? Up to 3 point something volts, up to 4 point something volts. In response to minus degree Celsius, once it comes to minus is already cold. So right? So it's now up to 4.2 voltage with this and 51.2 kilo ohm. You see the stuff. So if you are doing your normal calculation right here now, to know that if we are actually getting it, but if the voltage is actually running actually, you can put it 51.2 at this, 51.2 at this. 10 is already here. With that, multiplying this, you can know the voltage output and it will give you 4.294. That's why we talk about this calculation. So, okay, to get that, go to your draw, go to your output and labels. Anybody lost? Okay, tap it, connect it to this. Take it and connect to this side, from here and draw it. From that joint and draw it. Joint of that resistor. You see that? Anyway, you can draw it like this, draw it like this. Okay, this one, right? So to get that is a voltmeter. We are not actually using it for. We just want to use it to show the output that is there. It's not included in our circuit. But to get it, go to your draw, go to output and labels. Then go to you see your voltmeter and scope probe. So the scope probe. Are you seeing it? So that like, you get your voltmeter and then attach it. So for the person asking about GND, voltmeter to actually check the voltage, you touch positive and negative part with your probe. Or to check current, use it to complete circuit. Use a multimeter to complete circuit to check current. But for voltmeter, you touch the two terminals. Now we are now touching the output that is coming and down. Instead of connecting it, trying to connect tap it to ground. To have our general ground. So ground is not a component. It's, I don't know how to really explain it, but I think you really understand it. So now let's delete this because we are not using it. I think let's delete it. Yes, is that exactly? Thank you. That is negative part of it. Complete circuit. That's what it does. Just like they usually tell you that if you have a this power source that is coming out, this AC source that is coming out, if there's no ground, if you are not grounded, it will be floating. So until you are grounded, that's when you are electrocuted. So now you grounding yourself to ground to normal this thing, yeah, a complete circuit and not allowing current to pass through you. So which means if you can go home, if you can stand on anything without touching ground, you can touch the wire, no try am o, to the earth. Actually not should I use earth? Yes, you can use earth based on this symbol. It's also to complete I don't know, but just know that to complete circuit. Just to complete circuit. That's what we use ground for. Without ground, the circuit would not work. Yeah. Yeah. That's why when you said about it, I kind of don't know how to differentiate it, but normal this normal who does house wiring here? Huh? Okay, in normal house wiring, you have earth, you have live, then you have neutral, which is the other one. There's something they call it, not actually that word neutral. They use live and yes, neutral, right? Which is live is mains. Some call it mains when it comes to switch. Then live is the other one. The other one is neutral. Neutral is not the same thing with earth. So, but neutral is the ground. You get? But the earth is not the same thing with earth. Earth there now is to help you when it comes to shock. It not really make an impact on you that much. So with this, you already built a sensor, a temperature sensor. But you need to make it look more professional and really good. So this now will help us, will introduce us to some of those components we listed earlier. Thought we say something about diode, that it allows current to flow only in one direction, which means there was one time I was working with a team, and we almost at the time to submit something, to submit the project. We were working on the condition, so we almost time to submit the project. And somebody from our team, the person is just what he's doing there is HR, is not really in the technical part. He just came and I don't know how it happened. And somebody told him to just plug in the battery into the system. Actually, thank God that he didn't plug it to normal. Actually, even if you plug in the normal system, we have our diode that's protecting the circuit from reverse polarity. So, but instead of using charging module, we don't have time. So we bought a power bank module to charge the battery separate. So, but the power bank, we didn't know that the power bank module doesn't have reverse polarity protection. So the person now mistakenly reversed the battery, and the chip that is controlling the charging this thing burnt, like catch caught fire instantly inside that place. We are about to submit it, and the caught fire, like the whole thing just like bam. So we have to, by grace of God, somebody for our team have a one module before 4356. It's another charging module, so we just maneuver it, use small transistor to try to maneuver it and use it for charging. But we didn't actually know that it doesn't have a reverse polarity. So with this thing now, if this thing doesn't have a reverse polarity, if you mistakenly connect 5 volts here and connect ground the other way around, so now connect 5 volts here and connect ground here, you burn the whole thing. You burn the whole thing. But for this one, you not actually burn it. You not actually burn this because you can connect, it's just a resistor in series, just resistors in series. You can connect 5 volts here and connect GND here. But if you connect GND here and 5 volts here, you notice that it increase the temperature instead of the voltage to decrease, it will be increasing. So just vice versa. But if it doesn't burn this, other components that will be using like the LED to indicate that our system is on, and other things they will get burn, they will burn immediately. But this one will not burn, but other components will burn if you do reverse, if it doesn't have a reverse polarity protection. So now to protect this, we add a diode. So the current, this thing can only flow in this side. If my mistaken the person connects negative here and connect positive here, it will flow and it gets to this place, it will block and will not get to ground. And if it doesn't get to ground, you only have a floating voltage that's not grounded, so nothing will work. The system will not burn. So to get this, let's delete. You might delete or just leave it or adjust it. Then go to your drawer and get your diode. Or sorry, let me look for regular active components. You go to your diode and then draw it this way. It's supposed to be this way. Right click, go to your active components and get your diode and join it from here to this. Then now you can add your battery. Do you see this or it? Oh, sorry. Then you connect your battery. Huh? Input and sources for your battery. Then to get diode, you go to active components. You connect it to this place. Yeah, within between the battery and the resistor terminal, you connect it in between. No, one terminal voltage, one source. You go to input and sources terminal. Have you seen it? So you connect it. So with this, even if anything is done the other way around, our circuit is protected. Huh? One terminal. Yeah. So well, you need to also add some things because this thing is really highly sensitive. This one, the temperature change, the resistance changes in response to temperature. But this particular one is already meant to change like that. It's really sensitive than this. So for this now, maybe small thing now, the temperature will change. Small thing. So if we're having signals that is kind of so to filter it out, it doesn't have so it doesn't confuse our system. As the temperature is increasing and reducing, increasing, add a capacitor to filter that. But instead of adding, we don't say add a high values capacitor instead of 10 microfarad, 100 microfarad, add a 100 nanofarad because 10 microfarad will take time to charge up. It take time to charge up, but 100 nanofarad is mainly for filtering. It's meant for filtering. Oh, thank you. You also use capacitor. Don't worry. You can see my laptop. So one more thing you need to do is to add the capacitor. Yes. I think capacity is in passive components, and we have normal capacitor and we have polarized. Polarized capacitor is one that one side is positive, the one terminal is positive, and the other one is negative. If you connect the other way around, the capacitor will just blow up. But it's passing the reverse limit, it will just blow up. So for polarized, but for non-polarized, you can add it the other way around, add it. There's nothing wrong with it. So we can let's use non-polarized to avoid getting things nasty. Then you connect it between this resistor that is here, between this after the diode and out, like between the two. Because it's supposed to, you can connect it between here, but instead of connecting between here, we are using these two things to get the voltage out. These two resistors to get the output voltage. If you connect it here, you are not trying to get the output voltage, you are just trying to use some resistor. Understand? But connecting it to these two places because these two resistors is what you use to form the voltage divider. So you connect it between the two. So you tap here, and drag it to this point. Then get your wire and connect between here, mhm, between here to here, and the other one between here to here. So you see that it's already on 10 millifarad. You double tap on it and change it to 100 n, small n, nanofarad, or 100 nanofarad, the same thing as 0.1 millifarad. Is either you write 100 nanofarad, 100 n, or you write 0.1 small u, and you enter. Yes, it's either you add 100 n, which is 100 nanofarad, or 0.1 millifarad. With this, I think we need to do one more thing. If you notice, we already made it to be on 10k ohm. This place on 10k ohm, which means it's meant to be from certain temperature. Let's assume maybe this place is hot now, but it might not be detecting it right that much. But we can adjust it so it can be highly sensitive, so it can easily detect temperature and give us output. So to do that now, that's where our our this potentiometer that we said that earlier comes in. Use the potentiometer to adjust it. Like I said, potentiometer is also a resistor. 0.1 millifarad or 100 nanofarad. Just write 0.1 do or write 100 n. So automatically the thing will change to F. We add F on it. Are you done this? Done? Okay. Definitely. Everybody lost. Okay, so like we said earlier, now let's change the sensitivity of our temperature. This thing. Let's change sensitivity to so we can adjust it. So to do that, you go to your potential. This was it supposed to be in passive component? Yeah, I mean should be resistors. What active component? Oh, this potentiometer should be around active components or passive components. Let's check. Let's confirm. I don't know. Some passive component, right? Okay, go to your passive components and add potentiometer. Your passive component, you see your potentiometer. So you join it from this port to this port. That plate you removed the normal resistor, the 10k ohm resistor. Use the potentiometer to complete that place. That plate you remove the 10k ohm resistor. Use the potentiometer to complete it. So use the potentiometer to complete it. That was go to passive component. We don't know. We must play. The water police. 100 m using 100 farad. Then 0.1 u. Just add u to the farad. Then n nanofarad. Just add n now. N, yes. And okay. N. So it's only 100 nanofarad. It's nanofarad right now. So since you added the potentiometer, now go to your this thing and get your wire. Get wire and then connect this place from this point of that potentiometer. Also easy to complete. Also tap it on the positive part. Tap it on the positive part, on the 5 volt part, the input. Hmm? Tap it from here to the positive part, the 5 volt part. But still, this place is 5 volts. This place is 5 volts. What place is that? Let's see what you are using for it. So now, we are going to wire. Are you going to divide that? You cannot connect. Drag it to this joint. No, drag it to this place and then connect from it to this. Just like this. Are you going to maybe it's not connected. No, this is not connected, right? What is showing red is not connected. You highlight it and delete it. Highlight this one and it's close. Highlight it and delete it. And connect from this to this to this to this. This one, deleted this wire. It is not showing red. It's okay. It's connected. This is it the one thing potential? No, thank you. I just started to thank you. Are you aware? You aware? Remember, if your phone is showing zero, you are doing something wrong. If your phone is showing red, you aware? So checking happens here. Try to adjust this one here. So, please, oh, if you have if you have seen anything, just comment. So, right, double tap on this and change it to 10K. So 10K is now our max. So with this resistance, this thermal potentiometer. So you see that now, let's to make it this thing, you see that at that resistance, it's still on that temperature. But you see that if you change the resistance, the output voltage on this voltmeter will be changing. You see it. So if you leave it on something like that kind of 4K ohms, you see that slight change in this temperature will affect the voltage immediately. Just slight change in temperature will affect the voltage immediately. So you have changed the sensitivity. That is when you talk about sensitivity, change the sensitivity in your system. So slight change in temperature now can affect you because there is a potentiometer. Go to your on this side. Maybe, you see this side. You slide it. The other one is the other one is the resistance. Let's look at this. The voltage has to be before the diode. I think it's here, like not the floating. This is just a floating voltage. How to do this way now? Then the voltage will be before the diode. How to reverse this? Like to get this. Yes, then you take this one. So let's add another thing, maybe because with this now, we're just going to build the sensor, temperature sensor, like we said earlier. Let's now add our indicator to show that when you on it, our system is on, our system is off, also. The same thing, you go to your should be on output. That's you see your LED. You get your LED, have to take it from here, but let's give space where you add resistance. Or you can just add it. LED, yeah. Tap it from here. Okay, you see that when you're doing this, it's showing the voltage diode stuff, diode sign showing that it's a diode, light emitting diode. So after I've done that, eh, you draw it from this input after the diode, the 5 volts. But you know that this 5 volts will eventually burn our LED. So not that we might not burn it at immediately, but at a certain time, I burn it when it gets hot. So to do this, we add our resistor to reduce the this thing, the current flow. Now we add resistor here and add your ground. Input and sources. You add ground here. So this thing now, you see that it's on, showing that our system is on. So is this once you connect your system correct the correct way. Once you connect your system the correct way, it will show that our system is on. This is just indicator. And this one is this line that's coming out here now is the signal pin. Just like in a normal modules, normal like sensor module, you see VCC. What this resistor, 1K ohm. So you can use 220 ohm, but 220 ohm may allow more current flow. Maybe more enough current that's needed inside here. Not enough current that's needed inside the field. I use it for 220 ohm. 220 ohm can work. 220 ohm will even make the LED more brighter. But more current will not flow into it, and there's not enough current to go inside. So we normally use 1K ohm most of this system. So this one is the signal pin. This is now the GND pin. This is now the 5 volt pin. In your normal usual sensor modules, you see VCC, signal, and GND, or you see GND, signal, and VCC. The signal is now connected, is what you connect to your Arduino, your ESP, your Raspberry Pi, and some other things to control it. temperature change. Hmm? Add your drone to the end. So you'll not be noticing you change. So since I've done that, next thing is a what's time? Hey, time. We're not time is not on our side. Next thing to do is I don't know if we actually need to do this. Maybe if without using the sensor, this thing, you can see the indicator on the bulb based on temperature. If there is increase in temperature, the normal indicating LED is there, but then there's another LED that will be changing brightness based on temperature change. So let's add something like that now. So in that place, I'm trying to make sure we add all those components we added. So we're using transistor. There's something I didn't tell you about transistor. Transistor is came out of diode. Transistor was built from diode. You see, something like this. Sorry, something like this. I also see something like this. So this one is a NPN transistor. This is PNP transistor. The difference between these two is that for this NPN, if small current is added here, so it will allow say the one that's like you add the voltage here and add something here. You add small current here, it will complete this thing and make this thing allow this thing to flow. Like this thing will be connected and nothing will be flowing through here until you add small current here. Then it will key it on and make it flow. But for this one, it will flow in. If you add small this thing here, it will block it. Like vice versa. This place now is just like gate that is there. You put your battery here and you not get to this place until you open gate here, then to get to this place. But for this one, the gate is already open. Use this one to close the gate. For PMP, for MPN is vice versa. MPN you use this to open gates for the current to flow, but PMP you close the gate of that current that is already flowing for PMP. So for this our system, we're using MPN because we don't want the LED to on until there is signal that is coming out from that temperature. So it will now be changing. That's what we're using. And telling you about how it comes from diode. Um, was MPN, this one that's going out. This is the actual diode signal system of it. This is how it's formed from diode. For MPN, you can also use diode to make it for PMP. It's the other way around. For PMP. So all these things are diode. Even your those small ICs, they are diodes. That is all those things are made of diode. But from diode transistor to more advanced ICs. So we go to your active components. Active component. I think that's where you get your transistor. So NPN transistor. You get it and keep it around here. NPN transistor. You keep your NPN transistor around here. Huh? Okay. You keep your NPN transistor around here. Then you and one more thing. Why we be adding this? Normally, on norms, we can just bring I think one of you might be wondering why not just bring LED and add here so that the voltage that's coming out will just be changing. Yes, it's okay. It's okay, but one thing about it is that if you add it, it might affect our signal. Add LED directly from this thing to affect our signal. The LED will collect enough current and things that is flowing here will be affected. Signal will be affected. So we don't want it to be affected. We just need it to take small signal because this needs very small signal. In terms of voltage, it needs 0.7 voltage to activate. Yes, you can connect the resistor before the end. or maybe for remember if there's no this, it's not complete. So once there is this here, if you connect this here, so you're giving the correct thing to work. So before or after, it still works. So to do this, we get our transistor, and next thing is we get our LED, the one we'll be using. Go to your output and labels, go to get your LED and add it to here, to the collector side of it. Then get your resistor and add it also. So you see that if I add before. This thing now also, have you guys heard something about logic gates? Logic gates. So there's this gate, not gate, not gate. This is kind of similar to it. But to get actual not gate here, you have voltage that is out here until there is ground here. You see that not gate is always on. If there is one, it will off. The output will turn to zero. If there is one in, the output will turn to zero. But on norms is one high. So it means that on norms here, add wire. This place is 5 volts. If you connect it to, if you connect directly to, let's connect it. See that this place is high already. So norms is high, but on if there's ground, there's like this. So this place now will now go off. Like it's now off instead of being high, now go low. Instead of being one, it now turn to zero for your logic gates, all logic gates. So this thing is circuit for logic gates. That's what we want to input into our system to use. So you add ground here. You can duplicate this also. Huh? No, 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 emitter. Emitter. So now you add another resistor between this and this output and the base. So I think with this, our system is completed. It's complete. Nothing else. We change, okay, change this to 10K. Hmm? How do I write 10K resistor from this? Okay. Connect this wire and connect it to it. Yes, exactly. So to get the range of resistors to be here. I told you something about HFE, about this, about this breaker. Normally, usual LEDs in market, the maximum distance is around 5 milliamp for the maximum 5 to 20 milliamp. So it means that at 15 to 20 milliamp, sorry, not 5, 15 to 20 milliamp, that the LED is very bright, get very bright. So we leave it as our eye that we need. And then one more thing, the voltage drop, the main voltage that we need there will now be the input voltage, which is 5 volt that we have, minus voltage that is needed between this diode, this transistor base and the emitter. The voltage, this thing that is needed here is 0.7 for this normal transistor that we have. We have a German, no, not German, we have German that is 0.3, but normal one that is in the market is 0.7 volts. We have German that is 0.3 volts. But if for the one that's 0.7 volts, which is usual, rampant in the market, minus 0.7, you now have give you 4.3 voltage left. So already have your
Does it take 0.7 to start or
yes to activate it. So once I've done this, next thing is to do this current divided by the HF, which is for that transistor. You can also call it beta. This beta. So and beta for the transistor is 100. So already have your 15 milliamp. Let's take the lowest here and your 100, giving you this 0. What? 0.0 0.015, right? 0.015. Huh? Okay, 0.15. 2 milliamp. So you already have this now. Now you have your voltage, have your resistance, your current. So with this, I get the resistance, the actual resistance that need to be on the base resistance, which you know that your V equals IR. Now your R will now be V over I, which is 4.3 divided by 0.15 milli. Right? Remember, the milli is times 10 raised to 4 minus 3, right? So that will be giving you around 28,000 or maybe 30,000 ohms. Anybody with calculator can check it. Anybody checking it? Sorry? 4.3 divided by 0.115 times 10 raised to 4 minus 3, or 0.15, 0.000 negative 15, right? Okay. MPN. MPN. So if you get that, is that it will be around that 28,000 or so. So that is not giving you range of the capacitor we use to actually activate this base, this transistor base. Hmm? What's the why minus? Okay, don't worry now. So meaning that I'm coming. I'm coming. Increase in voltage, sorry. One na on the off, na on the off. Did you guys increase the temperature? Supposed to be when you increase the temperature to the maximum, that's when you're supposed to off. That's the reason I'm sorry. No, no. Zoom it out. Try to reduce the temperature. Temperature. Yes. Try to reduce it. Let me see this. You only do one. How? Supposed to off at maximum temperature and then still be when you have your medium temperature. Which one? Jesus. You try to change that to feel that. I don't think I see anything wrong. But what's that red dot between the potentiometer? No. The potentiometer and that this thing. It's not supposed to be red there. It's supposed to be to join yourself. That's why it is. It's high. There's one thing about Falstad though, don't refresh it. If you refresh it, everything is gone. So it doesn't save. It's not something you sign in. To save this, you see, go to file. To save it, I think we don't have that much time, but you can still have this and we go home, you still retrace it to go where you don't make a mistake because we are still following the same thing. I think we have time to be checking the whole thing. Go to file, then you see export as link, export as link, and then you export it maybe, save the link. You see, once you export it as link, you can shorten the link. You can shorten the link, but the link will be whole lot of this thing. You can shorten it to small link that you use later. So if you save that link later, if you come in and you go to that link, you come to this page that you read this. But if you leave this page now, everything is gone. So export as link. So you see that it's that big. So you create short link. Let me let you come. Export it. So I have to do one more. Okay, sorry, do not export it because here now you still have some voltage that will be floating here. I forgot to say that. Let me come back. Huh? When is not on it too? This is temperature. Is it 10K? Change it to 1K. The base temperature, the base resistance. Huh? Right now. Ah, to 10K. No, no, no. The base resistance. Change it to 10K. Let me check my list and whether it's connected. Save it so you can work on it later. For those that their own is not working, save it, still save it. I'll send this. So I'll send this so we can still use it to replace. Yeah. Yeah. That one is was supposed to because we actually did not cover what all the things we're supposed to cover today was that's it. And I beg I beg of you guys on Wednesday try to come on time. I thought about maybe also doing transformer side. Since we already do something like this now, can we do what's the time? I don't think have 20 that's 6:30. Huh? I got 20 extra 20 minutes. That's 6:30. Hmm? Okay. Let me check something.
For those of you that know, like this week, Monday, Wednesday, Friday, people are going to be discussing on electronics,
So, okay, let's just end here. Okay, remember, there's something I'm supposed to do here. I forgot it. Here now, you need to add a ground. Like, you need to ground this because if you leave it, you can have floating voltage also here. So this thing can easily actuate at any time and maybe try to confuse us and let us know that there is temperature, increase in temperature, whereas there's no increase in temperature. So to do it, we use another resistor, add another resistor from this base to ground, to ground. You get, so we change it to 100k. Sorry, yes. So what's this 100k ohms doing here now is that if nothing is connected to this place, if there's no voltage, there's no voltage here. If it's very small, this 100k ohm is we just ground it. It's called a pull down resistor. Then we have pull up resistor. Pull up resistor is to pull it up to high volts, maybe to 5 volts, and so to pull it up to 5 volts. Then pull down to ground it. So if there's no voltage, there's this. If there's no actual voltage, maybe half millivolts that's trying to confuse our resistor. This thing will just ground it direct. Yeah. So that's for this, and I think that's end for maybe today, and then from next class, I think we need to come on time. We need to come on time by 3. If it, do you guys have class on Friday, on Wednesday by 3? By 3. So we start from 3. So yeah, by 3. So we start from 3, and we start from 3. We first do power system. So this this thing is a sensor we designed. Just we design the sensor module. So the sensor module, they will use it for your embedded system part, which will be next week. Then we have to design a power module, the power system. So that will be using that's from AC to DC, from your normal NEPA to DC that will be using. Because normally, if you know that you plug your AC, plug your normal LED to this socket, you kind of burn, if you don't burn not burn yourself or you not burn the LED, you kind of burn the whole house because everything will just roast. So we have to want to find a way we can convert it so you can be using your AC down to 5 volts we'll be using. So we do that on Friday, on Wednesday. Then if there's time, no, there will be time. So we do the practical parts. Just some of them I already designed some of them, so I just show you some of them and then design maybe one right here. And then on Wednesday, on Friday, we do the PCB part. The PCB part might take too much time because we have to do schematic, the copper tracing, and then the 3D parts. I think that's it for the class. Can you guys, one of you guys pray for us? We forgot to pray for us actually. Somebody should pray for us. Anybody? Pray for us. Amen.
thank you for the session regarding today. As we use our resources, our Lord, Lord, help us to remember what we have learned. In Jesus' name. Thank you for our teacher. Grant him more wisdom to know more so that we can teach us.
Amen.
In Jesus' name we pray.
Amen. I think that's the end. Remember to export this so we can work on it better. If you refresh it, with love.